Thank you for sticking around. After this, you can go to the pub. Sadly enough, I have to fly back to Munich, so no pub for me. I would love to join you. My name is Deger. I'm from Rio, the logistics flow. This is a brand of Volkswagen truck and bus. And I will talk to you about cloud-native continuous delivery. A lot of buzzwords in one title. Please enjoy. So what's cloud-native? Cloud-native, I believe you might have heard this before, is the Cloud-Native Computing Foundation, which defines it as container package, dynamically managed, and microservice-oriented. For the purpose of this talk, the container part is not really the important part, and I also believe that cloud-native is possible without containers. For example, in my opinion, you should add serverless function as a service and all of those nice managed service offerings of the cloud to the mix to actually talk about cloud native. And I believe in this conference you heard enough about continuous delivery, but in its essence we want to have fast, reliable, and repeatable and traceable changes that we want to bring into production in order to get fast feedback and lower the risk. And we are doing continuous delivery for quite some time, and in this talk I want to emphasize what changes with cloud native, what additional opportunities and challenges we have, and how we can improve our continuous delivery approach and what we need to change. And cloud native, as we have heard, has something to do with microservices. So I will briefly introduce my personal opinion on microservices and why we should do them. Foremost, we want to gain speed, but not only speed in a single team, but also while scaling the organization. So this only makes sense if you have reached a certain size. Speed you gain by having fast local decisions and also by having autonomous teams who are doing those fast local decisions, and those autonomous teams are then making up the scalable organization. Those autonomous teams and their services, they are loosely coupled. They also have a strong boundary. So this is where microservices differentiate from other modularizations because they have these process boundaries. And this is then also very important for this talk. And for those fast local decisions, this also includes technology choices. So that within the microarchitecture of a service, teams can make their own technology choices if they seem to need it. Now let's talk about why this continuous delivery thing is actually important and how it used to be in earlier times. We had those dev departments which were driven by the need for change. We had the operations department which was driven by the need for stability, and there was a wall between them. They were siloed. In order to bring software into production, we need to virtually throw the software package over the wall. And those silos had a lot of dysfunctions to them. First of all, the time for the handover, the blaming, the operations team actually not being aware what they are putting in production. So a lot of continuous delivery and the DevOps movement for me is getting rid of those silos and getting to a true DevOps culture and have those cross-functional teams who actually collaborate and work together and also operate the services. Eberhard Wolf mentioned this already today if you heard his talk. If you still need to convince somebody that continuous delivery is a good thing, now we have actually science operating on it. So they're based on a survey, Chess Humble and others statistically proved that continuous delivery improves the IT performance, reduces the failure rate, and overall brings you a better organization performance. So if you reference this back, if there are any skeptics left. So now let's have a look at the deployment pipeline. I want to start with the most simple deployment pipeline I could come up with. You have a repository. In this repository, the application code lives for your service. Then you have your commit stage. You do your unit testing. You do everything in packaging that you require to actually be confident that you have a viable artifact which you produce. And then comes the delivery stage where you actually, perhaps over stages, but in essence, bring this artifact into production, hopefully without interruption, so that the new version of the software is running in production. As I previously mentioned, my favor for managed services, the first thing I would do, I would replace the Git repository with a hosted version. There are many options out there, GitHub being the most famous. Code hosting should not be done something that you should do yourself. Even though it's hosted, we learned that you still can make it secure. You have a big ecosystem in this environment. So this is, I believe, a viable option to actually, even in an enterprise environment, put your source code into one of those code hosting environments. Now, when we look back at the deployment pipeline, we have seen there are two stages, the CI and the CD stage. You can choose. You can opt to have one tool who's doing both parts of the pipeline. The advantage is the setup is more simple, and you have it's easier for you to get an overview of a pipeline. The disadvantage is you have one tool that needs to handle both. Especially, you should look out for a tool that knows the concept of a deployment pipeline. So don't just pick a good CI tool and piggyback the CD part onto it. The second option you have is to actually have dedicated tooling for both stages. Pick one of the existing CI tools, and depending on your environment and the platform you're running on, you could have a specific delivery tool. For example, on AWS, Spinnaker, or in other platform environments, there are similar tools with the purpose, which are fit for purpose for the specific job. But overall, you then have to manage the triggering part in there. As we already mentioned, the code hosting is a viable option to be managed. What about the managed deployment pipeline? Also a viable option, especially for open source. We have found in an enterprise environment we would not like to do that because the delivery part makes changes to production. So therefore, somehow the agent needs to access to production. This is not something we want to have in a managed deployment pipeline, with the exception, for example, on AWS, is if you use the respective code tools there, they have the built-in security to do that properly on AWS. Now let's look at our continuous delivery infrastructure itself. I believe the first thing you should do in a new project, start with your delivery infrastructure. If you don't bring your first service into production by hand, start with the infrastructure and grow the infrastructure for continuous delivery as your project grows. But be aware that then the initial version of your delivery infrastructure is not delivered by the infrastructure itself. So be aware that it itself does not become a snowflake. In case that something happens to your environment, you need your delivery infrastructure. So you should always go back and make this also automated. And also aim for that for your engineers, the delivery infrastructure could also be seen as a service, either by using a service directly or provide them as a service. So what new CI/CD practice can we use in this cloud-native world? Foremost, if you use containers, we have the build isolation. Whoever has seen a build agent who has Java version collision or Node version collision, all of those things that happens on a build agent over time, which breaks builds from other teams. So containers allow you to isolate your builds. It also allows you to have more elastic agents, so that in the morning when all engineers deliver new versions or before lunch, you don't queue up. And also the artifact that's coming out of your CI stage is then typically a container, which allows you to deal with the technical diversity better the autonomous teams can provide you. And also, as the mantra infrastructure as code also goes for pipeline as code. So aim for having the pipeline declaration also be part of your service repository. So shy away from configuring your pipelines in the fancy UI of the respective CI tool. This should come from code. This also helps you with setting up, setting up new services. So in a microservices world, bootstrapping a new service should be fast and simple. And a new microservice should also contain or should have its own delivery pipeline, which should also be automated in the setup. And of course, it's on the ThoughtWorks technology radar on hold for quite some time. Avoid the shared single CI instance for all teams. This will become a bottleneck. All the configuration goes through then the central team. Aim for also a decentralized version or a managed version which is capable of the tendency to handle multiple pipelines. Nevertheless, with all those new fancy things we now can do in our delivery pipeline, the old good learnings of CICD you should not forget about. So everything that used to be true about continuous integration and continuous delivery is still true. Be aware of the CI theater. So every commit should be on the main line. Take care of your red build. All of those things, you should still keep up those practices. Look for tools that embrace and help you with the deployment pipeline. And also a learning we had, try to not put the smarts into the CI tools. Those things are very powerful, but if you keep the smarts of the automation in your scripts, it's easier overall to manage the things and also aim for reuse and those kind of things. Now let's look at the infrastructure as code part. This is one of the advantages of the cloud. Everything is an API. I can create my infrastructure via code, and we want to make use of it. The most important part in there is don't treat your servers as pets. No server hugging, no server naming. Servers should be kettles. You have many of them. You kill them if you need new ones. No naming there. And I would even go a step further. I'm not interested in the cattle anymore. So I want the meat out of the thing, aiming for serverless or other higher level abstractions, which also gets rid of the server or even the container. So how does our delivery pipeline now change in this cloud native environment? I still have my repository. I still have the application code in there, but now I also have the infrastructure specification in the service repository. And in my CI stage, I'm still building the artifact of the service, but I'm also packaging up the infrastructure declaration. And when rolling out a change to the service, I first create or update the respective infrastructure. And as a part of that change, I also start new instances with the new application. But the infrastructure changes are applied through the same pipeline as the code change moves. This gives you the advantages you had from the normal delivery pipeline, that all changes are traceable, repeatable, and all of those things you also now have for your infrastructure. It goes through the same pipeline. There is conceptually no difference. But when we treat infrastructure as code, we also need to take care that we learned around code to have good engineering practices and to think about structures. So as we have talked now about microservices, some of the patterns we also should repeat for our infrastructure, and we should be aware of the infrastructure monolith. So don't have the big Terraform or the big CloudFormation template, which creates all of your infrastructure. And you should also, this picture might aim at that, shy away from a layered infrastructure approach. I define all the databases here. I define all the load balancers in a separate layer. So all the patterns we learned which are not good in code, we should repeat in the infrastructure level, and we should decompose our infrastructure in micro-infrastructures so that we follow the boundary of the microservice for our infrastructure. In our case, we did all of the work with CloudFormation. We had at least one stack per microservice. So it's totally viable to have more stacks in there, have a different declaration for your database and for your load balancer, still being in the same repository, but not all changes applied to one stack at once. But the boundary for this microinfrastructure should be the microservice. And then we have the macro infrastructure. Eberhard today mentioned the differentiation, or in the principles, the differentiation is between macro and micro infrastructure is mentioned. For your macro infrastructure, have a separate or separate stacks which declare the network, the security, the bastion host, the minimal set you need to set up your macro infrastructure. It should be as small as possible because this will be the thing that's hard to change. So you need to have tests for this, and you also should reduce the number of moving parts in there to what's actually really required. And no services should be part of the macro stack. This is the environment we deploy into. And then in this macro infrastructure, we deploy our microservice stacks. And in the case of CloudFormation, there is a concept of input and output parameters. So the parameters of the macro stacks are fed into the service stacks. And the service stack is owned by the respective team who owns the microservice. And all services are in those microservice stacks, even parts which could be deemed as being part of the infrastructure. For example, your logging infrastructure or the delivery infrastructure, those parts should also be in those microservice stacks. Any questions up until here? Okay. Now, isolated deployment pipelines. If you have many microservices, you will end up with many deployment pipelines, and those microservices might have dependencies. Foremost, they will have a dependency to the continuous delivery infrastructure, of course. They also have a dependency to the macro stack. But for example, if running on EC2 or with containers, you might also have a dependency, for example, to base images. What we initially did, our fancy GoCD tool allowed us to model those pipeline dependencies, so that whenever a base image was changed, the delivery pipeline for the base image, the respective service pipelines were also triggered. Seemed like a smart idea, actually managing the dependencies like this. In reality, it's not such a good idea, because whenever the AMI was changed, all microservice pipelines were starting to run. If something was wrong with the base AMI, we would break all dependencies at the same time. So, as with all the other things, we learned decouple those pipelines. There are alternatives to manage the dependencies, have them pinned, go through the extra hassle of explicitly manage the versions of those dependencies and deliver those changes explicitly, and do not couple yourself. So that actually the decoupling in the pipeline is something where you should aim for. Now let's look at the deployment itself when we are putting something into production. I totally believe in the idea of you build it, you run it teams. This is for me the essence of DevOps. The team is responsible, and in this context also not only for running it but also for deploying it. If now one of those teams, and we have many of those, bring their service into production, the question of the staging environment comes into play. In this example, let's say the blue team and their blue service is in the staging environment with version 2 of their service and is verifying that it's working properly with the version 6 of the yellow service. Everything is fine. The tests are green, the integration works, and now V2 of the blue service goes into production. What happens? It's now integrating with version 4 on production. So conceptually, you have the safety of your staging environment to verify that the versions you're integrating with actually work. But as many people deploy many times per day new versions into production, this is a fallacy, because now you're verifying that it worked with the newer version of the service, but in production you might meet an older version of the service. In the end, what we decided upon is that we actually don't want to have the staging environment and all of those pre-production environments. We integrate in production, and the first thing typically people say, this you can't do this. This is totally dangerous, and they find a lot of ways why this is a bad idea. But I believe that we have now all the toolings in place to release into production with confidence and avoid all the grunt work of keeping the staging environments up and running, making sure that they are like production, all of those pains. The work we put in those, we avoid this and now put our engineering capabilities in still having the confidence to do this in production. One thing is to do consumer-driven contract testing, explicitly to avoid the scenario I've shown in the slide before. Also, by reducing the impact of failures, if you go into production, things will go wrong. Your staging environment will not protect you from everything you're hoping it will protect you from. So try to reduce the impact of failures. If something goes wrong, also be able to recover fast. Emphasize monitoring for this. There are techniques like Canary Analysis and having fast rollbacks, and also observe your production environment. Tools like semantic monitoring helps you there, that you actually emphasize the monitoring part over the testing part. Nevertheless, you should still do tests, but less emphasis on tests as a gateway to production and more on observing and making sure things are working fine in production. One of the tools that also helps you there to manage deploying into production with many microservices is the concept of feature toggles, to actually separate the code deployment from the feature release. So the new feature is turned off and all potential, and you wait until all respective services are in the production environment, and you also have the freedom to do canary releases on those feature toggles, etc. This also means, who is doing feature branches, by the way? Okay, that's always the fun question. Please, if you take one thing away from this talk, look up on trunk-based development and feature toggles. Continuous integration on feature branches is not really continuous integration, and it makes you over time faster and more reliable if you actually, all of your teams work on the trunk, or all team members work on the trunk, and you separate new features via feature toggles and not via feature branches. Another thing you can do with those feature branches, with those feature toggles, excuse me, that you actually can hand over the responsibility for releasing a feature to product, because now it's no longer a code deployment, it's the switch of a feature toggle, perhaps even, and this is one of the UIs we have built, it nothing fancy, but the product owner now can control how many of the users or whatever segmentation you pick there are seeing the new feature. You can do canary releases by just exposing the feature to few of your customers, and you can also use the same mechanics to do A/B testing. So feature toggles is sliced bread for continuous delivery. Now let's look at the immutable deployment patterns. We talked already a little bit about the immutability and talking about the infrastructure as code, and this is something the cloud allows us to actually not to change anything while it's in production, because there are virtually unlimited resources for us. So whenever we want to deploy something new or change something, we have the luxury to actually bring a new version of the service into production and remove the old one. So let's look at the immutable deployment patterns. If you're using function as a service, like Lambda functions, serverless, you're already done. There is nothing you have to do. This is completely abstracted away from you. You just use what's available. If you're still in the container or in the service world, typically the lifecycle of such an immutable server looks like this. You create a version of the service. You verify that the health check is okay. You activate the load balancer to actually send traffic to this version of your application. And depending on your release frequency, after some hours when the next version comes along, hopefully with a high frequency, you drain the connections on this server and then terminate it. This also means that there is no need anymore for tools that actually change what's happening on the server, because you recreate them all the time. Things like patching and security is now more under your control, because, for example, you do the patching on the base image and make sure that in a regular interval new services are delivered. We, for example, introduced an alert on the age of a service. The rule is no service should be, for example, older than 30 days. Because then we cannot guarantee that all the security patches are on there. So if for any reason a service has reached a maturity level that actually nobody is working on it anymore, at least every 30 days he needs to be delivered. And of course this pattern is easier with stateless services. Nowadays most of our services can be stateless. We push the state up to the client, or we push it down to one of those fancy cloud-provided databases like DynamoDB or whatever, who handles the state for us, and we don't actually need to manage it, leaving us with the luxury of living in this stateless world. But also modern cluster distributed persistence like Kafka or whatever can be treated in a similar way. Not that simple, but very similar. So what do we have then? We have, for example, the rolling update. The pattern is rather easy. I have 3 running in production. I want to roll out version 4. I add a new instance in version 4. Health check is okay. Load balancer sends traffic to it. And I can drop one of the old instances and rinse and repeat, start a new instance of version 4 until in the rolling update only the new version is running in production. The advantage of that pattern is only a few additional resources are required during deployment. So I'm having all that example 3 in production, I add 1, but it takes some time. It's a stage rollout, but it also gives you then some more security because you're adding only 1 there. Another pattern is blue-green. You add the same amount you have currently in production, add in as a new version, health check is okay. Load balancer puts traffic on the new version, drains it on the old version, and then you terminate the old version. You can keep the old versions around for a fast rollback, depending on the timing you have there. But if now something is wrong in version 4, it's now very easy and very fast to switch back to version 3. And then you finally terminate them. Disadvantage, not so important in the cloud environment, but you need during deployment double the resources. If you do this in a data center environment, this is an expensive option. In the cloud, not so much. But overall, the deployment is faster because you don't have to go through the cycle instance by instance. An even more advanced pattern then is the Canary Analysis. Similar to the rolling update, I bring up a new instance in the new version. But now I'm doing a more thorough analysis of what's going on with this new canary. Who knows the canary pattern? Was a bird in the mines. So in the mining, they have taken a canary down there, and he was more sensible to the poisonous gases. So if the canary died, the miners left the mine. And in our world, the canary verifies the error rate, the latency, and the load. If everything is fine from those requirements, nothing is going wrong with this thing, then only do we continue with our rollout strategy. So if something happens to the customers who where the traffic hits this version, it's only a limited impact. So you try it with real users, with real traffic, but with a limited set. An alternative to instead of doing this with a physical instance you add to your stack, you can do the similar thing with feature toggles, where you just enable the new feature for a subset of your users. But that's not possible for all kind of changes. So the infrastructure-based Canary is more powerful there. Another option you have with immutable servers, and which also gives you some confidence, are the dark launches. So you have a client who is talking to an existing service that is in production, and you want to introduce a new version. This is typically not a feature change, but a more drastically. You are refactoring, replatforming, or whatever you're doing there, but you introduce a new version of the service you want to verify. And you then, either from the client or via a proxy, there are many different options, but you fork the real traffic and also send it to the new version of your service and actually discard the response. So this is just you're doubling, you're forking off the traffic and hitting the new one, and monitor how the service behaves under load. You can also, instead of discarding the response, compare the response of the new service against the old service, whether they're actually delivering the same result. And as mentioned, you can do this on the client or on the server side. The advantage of the dark launch is that the new service is capable, if you have gone through these exercises, you are certain that it's capable of handling the same thing that the existing service does. So when you then actually bring your new version of the service in production, you have less surprises. So wrapping it up, recommendations for the deployment pipeline. Take care of build isolation. Take care that your pipelines are actually independent from each other. The cloud, with the cloud native approach, gives you the elasticity that nobody has to wait for your delivery pipeline. Try to aim for everything as code, including the delivery pipeline, including your infrastructure, not only the service itself, and give the teams the autonomy to actually own their own pipelines. Metrics to watch out for or to optimize for in this continuous delivery environment: the lead time, the time it takes from a commit until the change is actually in production. In a microservice environment, important, the time to bootstrap a new service, and this includes the infrastructure and the deployment pipeline, because otherwise people will build functionality in existing services if it's too cumbersome to bootstrap a new one. Then, of course, the deployment frequency, that the teams are actually in a shape to continuously deliver many times, hopefully per day, per hour. And, of course, to get the benefit, if something breaks, you should take care of your mean time to recover and optimize for that. Things will break. It's only a matter that you are able to recover fast. So you build it, you deploy it, you run it, you embrace the immutability, your infrastructure follows the microservice architecture, and failure will happen. You need to be able to deal with them. Thank you very much.